So the next example is still the second order ODE, but how about we use different boundary conditions instead of using the Dirichlet boundary condition? How about we use Neumann conditions? How about we use Robin conditions, right? So how about we change the boundary conditions to y0 equals to 1. Instead of y pi equals to 0, we change to y pi prime equals 0.115. Okay, so this is Robin conditions, which is a mix of y and y prime. And what has been changed? What has been changed? So instead of the yn, you don't know yn now. So yn is unknown as compared to previous solutions. So before you only have y1, y2 until yn minus 1 is unknown. Right now, your yn is also unknown. Okay, also unknown. And for the boundary conditions, okay, for the boundary conditions, you have yn prime equals to 0.115. And how we can write algebra equations to represent yn prime using finite difference method. So we can use backward ruler, which is the most straightforward. You couldn't use forward ruler or central finite difference, central difference, because you don't know what is yn plus 1. That is outside the range of our x step, right? So we can use backward ruler, which is yn prime equals yn minus 1 divided by h, which is your step size. That is 0.115. Okay, and you can rewrite this as algebra equations with the coefficients minus yn minus 1 plus yn, that is 0.115h, right? All the other equations will be the same, but the right-hand side boundary conditions are different. So the final form of you state space matrices equals to B have been changed. The size has been changed. The format has been changed, but slightly changed. So you have to figure out who is your unknown. So before it's from yn, y1, y2 until yn minus 1. That is the previous version when your yn is known. But right now yn is unknown. So you has been increased the size for your y is from y1 to yn. Okay. Then the coefficients for the left-hand side boundary will be still the same. B1, C1, 0 until 0. A2, B2, C2 to 0. Then 0, A3, B3, C3 until 0. Then you have this is A n minus 1, B n minus 1, C n minus 1 for the yn. The right-hand side will be similar as before, h squared r1 minus a1 alpha. The alpha is represented by y0, which is 1 here. You have h squared r2, h squared r3 until h squared rn minus 1. But the right-hand side boundary has been changed, which is -1 for the yn minus 1. Yn is 1. Then you get the right-hand side is 0.115h. So now this become your state space matrices. And you can see that when you change the boundary conditions, right, the boundary condition type, you will change the size of your state space matrices as well as how you can write the left boundary and right boundary. Then as a practice, how about you change to the boundary conditions, the boundary conditions to y0 prime equals to -5.4714, y pi equals to 0, So that means your left boundary has been changed, but the right boundary will be kept as before, right? Then when you can solve for the y0 prime, you can use the forward ruler, right? The forward ruler, which is the most straightforward. You couldn't know what is y-1, but you know what is y1 and y0, so you can use the forward ruler, y1 minus y0 divided by h, and you can get the left boundary, right? The left boundary will be negative y0 plus y1 equals to h times negative 5.4714. So instead of the first row is b1c1 to y1, your size change from y0 to yn minus 1. The first line will be negative 1, 1, and then the right hand side will be h times this negative 5.4714. And the other rows will keep similar. The second row will be a1, b1, c1, the y1, and with h squared r1. So you can try to write by yourself and trying to solve by yourself and see if you can write when the boundary condition has been changed. Okay.